Hey, welcome back, students. In this video, I want to go ahead and focus on balancing the reaction once you've actually made the prediction. Now, this is going to be very similar to what we've already done before. When we balance chemical reactions, you do want to make sure you go through these steps. Divide out the reaction here. This is the left side, this is the right side. And then you want to go atom by atom, making sure you have the same numbers on the left as you do on the right. So what we'll do here is we'll begin with sodium. Notice we've got one copy on the left. Find the sodium in any compound on the right, which is the product side, and notice we've only got one copy there. So that one's fine because we got one copy on both sides. Next thing, go to the next atom. In this case, it's chlorine. We've got one on the left, and we've got one on the right, and it does not exist in the other compound, so there's only one copy. So that one's fine. The lithium here, one copy on the left, one copy on the right, and then the other thing that's left to do here is look at the hydroxide, but keep in mind that the hydroxide is a polyatomic, so we have to treat these together, both the oxygen and the hydrogen. There's one copy on the left, and there is one copy on the right. So here, definitely, we have only got one copy of each, so what we've got to do at this point is just go ahead and write down the actual coefficients. And so the coefficients here are going to be let me just go and put those boxes on so that they don't mess with us here overall. But we notice here we've got one copy here, one copy there, one copy there, and one copy there. Right? And so that's really all it really is in terms of balancing. Just count the atoms on both sides, make sure you have the right number, and then from there you can actually go on. So this is one example. Let's go ahead and do another one. I'll go ahead and predict it for you, and then I'll balance it right after. Okay, so let me go ahead and do that now. I'm going to go ahead and clear out the screen here so we make some room. And so let's see here if I can do this way. Let's just go ahead and clear everything out. Okay, so here's another reaction that you'll get. Let's just go ahead and do this one here. We're going to take calcium nitrate, and we're going to need 2 copies here, plus aluminum carbonate. There's 3 copies, and we have to make the prediction. So quickly, let's go ahead and predict this out. Remember, divide it out, positive and negatives, and then actually put the actual charge up top to kind of help you out. And you got to do this now, the placing of the charges. This is +2, and inside is -1, but there's 2 copies, so overall we got a -2 there. This is a +3 and a -2 here in the center. So actually, what we forgot to put here is we need to put a subscript here on the aluminum. And so there it is. Now we got to make the prediction. So we already know that the positive is going to react with the negative, but what we don't necessarily know is whether the aluminum is going to displace the calcium or if the calcium is going to displace the aluminum. And so you'll really need to look at your activity series for that. Okay, so go ahead and take a look at that now. Give you a second. And then what we're really asking here is calcium, is it greater or less than aluminum? So we're really making a little bit of a competition here and figure out, are we either going to put it greater than or are we going to put it less than? And if it's less than, then obviously any product formed by aluminum is going to go first. And if it's greater than, calcium being greater than aluminum, the first product that's formed is the one involving calcium. So go ahead and take a look at that, and then we'll make the prediction here in a second. All right, so if you had a chance to look at that, you'll notice that calcium actually is going to be at the top of the series. And so here's what it actually looks like if you're looking for the activity series. Here's the actual order. Let me go ahead and write it over here on the right-hand side. And so the activity series, and it actually begins with lithium, followed by potassium, followed by barium, calcium, sodium, magnesium, and then right after that is going to be aluminum. And there's actually others. There's manganese and whatnot, but we're only going to be looking at these. And so what you're looking at here is you're going to be comparing calcium with aluminum. Notice that calcium is higher than the aluminum, so therefore calcium here is going to be greater than aluminum. And so the very first product that we actually form is going to be the product involving calcium. And so what you'll find happening here is that the calcium here will combine over here with the carbonate, forming the first compound, and that compound is going to be calcium carbonate, and then the other compound that you're going to form is going to be the aluminum nitrate, and so that'll be LnNO3. Okay, and so At this point, you need to go ahead and transfer charges. So this is +2, -2, +3, -1. The disparity is going to be with the aluminum and nitrate because these charges are not going to give you 0. The calcium and the carbonate, that will give you 0. That's actually a neutral compound. So we can actually leave that alone for the neutral, but the other one is not neutral. And so what we'll need to do is actually crisscross the charges here, but I am actually going to have to put parentheses around the nitrate. And then I'm going to put the subscript of 3, and I'll put that in red just so you can see it better. Okay? And so that there is the actual prediction. All we need to do now is actually balance things out, and I'm going to actually choose a different color for that so that we can actually make it a little bit better to look at. And so we'll start here with the very first atom. Notice we've got 1 calcium on the left, 1 calcium on the right, so we're good to go. Here for the nitrates, you actually have 2 copies of nitrate. So go to the other side and find out how many nitrates you have on the right-hand side. If you're not sure where the right and left are, it's actually here where the arrow is. This side is left, this side is right. So there's actually 3 copies over here. So we've got 2 on the left, 3 on the right, and we need to look at the least common multiple between these two. So we've got a 2 and a 3. If we multiply them, that'll give us a common multiple of 6. So the question here is, how do I get a 6 from 2? Well, the only way to do that is actually to get 3 copies of this. So we're going to add a 3 here. But notice that when we did that, we actually created a situation with the calciums. Now we've got 3 calciums that we need to resolve over here on the other side. So we're going to have to put a 3 right here. And now we've resolved the calciums. And the carbonates have generated 3 copies of the carbonate, but that's okay because we've already got 3 copies of carbonate over here anyway. Okay? So the only thing that we need to do is go back to the nitrates. Over here we've got 6, but on the right-hand side we've only got 3. So some number times 3 will give us the 6. Obviously, we already figured that out. That's going to be a 2, so we do need to put a 2 in front there. That will give us 2 times 3, 6 nitrates, and now we've resolved the 2 aluminums that we created over here. So this actually is a balanced equation. All we need to do is put the 1 here. And so the actual balanced coefficients that you're going to need here are going to be at the bottom. Let me go ahead and write them. So here in the box, so that your coefficient order is going to be 3, 1, 3, and 2. Each of these corresponding to the various positions here in the overall reaction. Okay, so I don't need to actually label them, but I did want to show you where they were. Okay, so that's how you go ahead and balance a predicted reaction, or when you've actually predicted the products of a chemical reaction. That's how you go back and balance it. Just using some of the skills that we've already used in the past. Just keep using them as you go through. The new business here that we learned was the activity series, very important in predicting whether a reaction takes place or not. If the activity series is greater for one cation versus another, then definitely that cation will replace the other one with the lower activity series, but not the reverse. So aluminum would not replace calcium, but in this particular case, what happens is calcium does replace the aluminum, and then the aluminum combines with the remaining anion. Anyway, that is actually how you predict it and balance it. So if you have any questions, see me during tutorial. Keep watching, keep learning, and we will see you in the next video.